Everybody. My name is Nicole Abuzo, and I'm here to demonstrate you the two programming projects I created for my senior project and portfolio class. The two projects consist of programming names called Shift Cipher, and the other one is called Avalanche Effect. So we'll start off with Shift Cipher. Shift cipher is also known as Caesar cipher, which was used by Julius Caesar around 58 BC. He used this to shift each letter in his military commands to make them appear meaningless. So let's see and run this program. So to run it, you'll do just I've already compiled it. As you can see, you type in Java shift cipher, the program name, and this program takes four arguments. You will do either dash E or dash D. E is for encryption and D is for decryption. Right now we'll do a dash E to encrypt a file. So uh, inside your folder, there's actually a file called encrypt input. You can uh, put something in it, whatever you want. Hey there, and this will just control save, and this will just encrypt the message. So when you run it, you will have to type in the name of the file, which is encrypt input.txt, and give it an index number from 1 to 26. Let's say 5, and we'll name the output file new output.txt. You can name the output file whatever you want, really. And when you run it inside your folder, oops, wrong one. Inside your folder, there should be an output, and the new output, it's gonna look gibberish, of course, and it's supposed to be meaningless. So now let's try and decrypt that file. Okay, erase all that. And instead of dash D, we do dash D. And instead of encrypt input, we do the new output dot txt. And of course, we already know the index key, which is 5, because we just run it. And we also, and then we can name it decrypted dot txt. All right. And if you look at the folder, see, there should be there you go. There should be a file name called decrypted, and it should shows you the same message as you have inside your encrypt input text file. And that's what shift cipher is consists of. Now let's go to avalanche effect. Avalanche effect is calculated by changing one bit in plain text, keeping the key the same. By changing one bit in encryption improves the level of the security. So let's see and run the program. So to run it, you'll type in Java, the program name, which is Avalanche Test. And this program takes three arguments. So you put dash C for compare, and then key pair.txt. So where this key pair came from, inside your Avalanche effect, there is a text file called key pair, and if you look at it, there's two information. This one is the key, and the next one is the plain text. So if you close that out, you can also find more key pair text on Google if you want to. So we're going to be using that specific file to compare each number of flip bits. So for this one, we'll have keeper.txt, and then we'll output the information into a new text file called new output as well, and hit enter. Oh, and as you can see, there's already a new output file text generated, and on your command prompt, there's all this gibberish. It's kind of hard to understand if you don't really know what they means, but let's get on them one by one. So let's open the key pair first. As you can see, this key is also printed out on your command prompt, and the plain text is also on there. So this too is used to generate a ciphertext, and the flip bit is 0. So as you can see, the flip bit will be from 0 to 127 inclusively. So each of this is the decimal form. Each of these decimal numbers has a binary equivalent. So 0 will be 000. Same thing with the second 0. And for 1, it'll be 0001. 2 will be 0010. So on and so forth. So the first bit is coming from this first plain text number. And those right there, it generates a new plain text and a new ciphertext. And it counts the number that's been flipped. It compares the original plain text from the new plain text and from original ciphertext and the new ciphertext. All right, and inside our new output is almost the same thing, but instead of having all the new ciphertext, new plain text, it doesn't include that. It only includes the plain text flip bit and the number of flip bits. And if you look at the graph that I created, you can see that the x-axis will be let's see. The x-axis will be the number of flip bit from 0 to 127, and then the y-axis will be the the average number of bits flipped. Okay, and as you can see the graph, there is no weak index for flipping a bit in a plain text. The number of bits is flipped is distributed randomly that creates confusion and diffusion. This is how I demonstrate my avalanche effect. There isn't really any weak indexes because each of them that's been flipped is yeah, it comes out with random numbers. And as you can see, the average is 63.5, and the average of number bits flip is 64.758. And that concludes of how I demonstrate avalanche effect using AES. And if you have more questions, feel free to contact me, and under my description I will have my GitHub link to know more information about symmetric cryptography and how is this important to us in our current security world. It explains the Caesar cipher and the avalanche effect, and how does the symmetric algorithm improve throughout the year and how it influences our current crypto system. And that's all I have for my senior project. Thank you guys for listening, and I hope you all have a good day.